So, what if the universe isn't fundamentally built on, static particles? Or these mysterious invisible forces we talk about? What if it's actually based on something way more dynamic, maybe more elegant? Pure motion. Welcome to the Deep Dive. Today we're really digging into the legacy of James Clerk Maxwell. He was this brilliant Scottish physicist, and his work didn't just shape modern science. Some new ways of looking at it suggest he might have defined science in a way we're, well, only just starting to fully appreciate now.
That's absolutely right. Maxwell's big achievement, what we now call Maxwell's equations, I mean, it was monumental. He managed to unify electricity and magnetism, pulled them together into one single framework. Electromagnetism. And this wasn't just some abstract theory, right? It literally laid the groundwork for, well, pretty much everything we use today. Radio waves in your phone, your Wi-Fi.
Right.
Even the concepts that eventually led to quantum physics. It's huge.
Okay, and here's where, for me, this deep dive gets really interesting. Because mainstream science looks at Maxwell's equations one way. But there's this newer perspective. People call it motion theory. And it argues Maxwell wasn't just describing fields.
What does it say he was describing them?
It suggests he was actually capturing how pure motion itself structures itself, how it organizes when it interacts. So our mission today is to unpack that, not just what he discovered, but how this, let's say, reinterpretation suggests he found the blueprint for motion's interactions, these gradients of motion.
Okay, so like Newton described the steps of motion's dance.
Exactly. And this theory says Maxwell maybe wrote the music for it, the underlying rhythm that makes the whole dance possible.
That's a really compelling way to frame it. So by the end of this, hopefully you listening will have a maybe startling new appreciation for Maxwell, for his genius, and how his work, seen this way, might be the key to seeing all fundamental forces as just different arrangements of motion.
Yeah, get ready for some potential aha moments. It could definitely shift how you think about light, energy, maybe even gravity.
Definitely.
So let's set the scene a bit. Before Maxwell came along, scientists mostly saw electricity and magnetism as totally separate things, right?
Completely separate phenomena. Yeah, sure, you had pioneers like Michael Faraday doing experiments, and they hinted there might be a link. But nobody had the math. Nobody had the framework to really explain how they were connected.
Until Maxwell.
Until Maxwell.
Right.
He stepped in with these incredible mathematical insights, particularly about fields.
And what was so revolutionary about his approach with these fields?
Well, he showed that electric fields and magnetic fields aren't really distinct things at all. It's more like a feedback loop. He demonstrated that a changing electric field generates a magnetic field. Okay, that's one part.
Right.
But crucially, the other way around, too. A changing magnetic field generates an electric field. They create each other continuously.
And motion theory looks at that loop.
And interprets it not just as an interaction between two things, but as one continuous self-sustaining loop of pure motion itself.
Okay, I think I'm getting that. This is where the motion theory angle really starts to diverge, isn't it?
Exactly.
So from this perspective, Maxwell's equations aren't just describing waves like light waves. They're describing these structured patterns of motion, like motion gradients.
Motion gradients that lock into this rhythmic back-and-forth exchange.
So an electric field isn't some invisible force field hanging in space.
According to this view, no. It's more like a dynamic slope, maybe a directional flow within this motion fabric, creating a kind of push or pull.
And the magnetic field.
That's the ripple, the perpendicular flow that gets generated whenever that first motion gradient changes. Think of ripples spreading when you disturb water.
But the water is motion itself.
Precisely. The medium is motion.
Okay, that leads to a big question then. If they aren't things occupying space, what are they?
Well, motion theory suggests that what we perceive as E and B fields are actually these rhythmic distortions, patterns within an underlying omnipresent motion fabric or substrate.
A fabric of motion.
Yeah. So the wave nature of light, for example, isn't about little particles zipping through space. It's about these electric and magnetic motion patterns constantly trading their rhythm back and forth, sustaining each other like a continuous dance.
And that reinterpretation suggests Maxwell stumbled onto something huge, maybe without even fully realizing its implications at the time.
Possibly. That motion can literally store itself. It can exist as a self-sustaining cycling pattern, even in what we think of as empty space.
That is. Yeah, that's pretty mind-bending, especially when you remember what happened when Maxwell first solved his equations. The math itself predicted a wave.
A self-propagating wave, right. And the calculated speed of that wave.
It matched the known speed of light. perfectly.
Exactly. So, mainstream science understandably concluded light is an electromagnetic wave.
But connecting that back to motion theory, light then becomes this freestanding loop of motion, self-synchronizing.
A self-synchronizing loop constantly cycling between those E and B motion patterns. And crucially, nothing material has to move through space for this wave, this pattern, to travel.
Which would explain why the speed of light is constant.
Motion theory interprets it not just as a speed limit, but as the maximum rate of synchronization possible within this fundamental motion substrate. It's the universe's internal speed limit for propagating these motion patterns, this information.
Okay, this feels like a good point to bring up the whole ether problem. Maxwell lived in the 1800s.
Right, and like most physicists then, he figured these waves needed something to wave through, a medium, just like sound needs air or ocean waves need water.
He called it the luminiferous ether. Seemed logical.
Totally logical. But then you had famous experiments like Michelson-Morley specifically designed to detect this ether, this medium that light was supposedly traveling through.
And they found nothing. Absolutely no trace of it.
Zilch. So, mainstream physics, quite reasonably, said, okay, guess there's no ether, and eventually discarded the idea.
But motion theory, does it bring the ether back?
In a way, yes, but it's fundamentally different. It's not a physical substance filling space. Instead, the ether, if you want to call it that, is the motion substrate itself. Space isn't empty. It's this dynamic field of pure, maybe unresolved motion loops that can take on structure.
So waves don't travel through it.
They are patterns, phase relationships within it. They are the structure of the motion fabric itself.
Wow. Okay, that's a completely different picture of the universe. And if you look beyond the, let's face it, pretty intense math, Maxwell's equations, viewed this way, seem to describe some really basic rules about how this motion behaves.
Exactly. They lay out rules for how structured motion interacts. For example, motion theory talks about a loop divergence rule.
Which means?
It basically suggests that motion patterns that aren't perfectly aligned or synchronized, maybe they're converging or diverging, create a directional imbalance, a push or pull.
Which we experience as electric charge.
That's the interpretation.
Right.
And then there's the loop curl rule.
Let me guess, magnetism.
You got it. It describes how a changing motion pattern forces a sort of perpendicular adjustment in the flow. That's the magnetic response.
And Maxwell's equations also implied no magnetic monopoles.
Right. Which in motion theory terms just means motion loops are always closed. They don't have loose ends. You can't isolate a single magnetic pole or charge.
It's always a loop.
Always a loop. And finally, there's loop induction, how changing motion patterns actually create those perpendicular gradients that reinforce the loop, helping it sustain itself.
So these aren't just abstract laws about fields anymore.
They're seen as the fundamental ways structured motion organizes and sustains itself, the inherent behaviors of motion.
The impact of Maxwell just getting the math right, regardless of the interpretation, has been, well, immense. Modern tech is built on it.
Absolutely. Think radio waves. Motion theory might see those as really spread out low-frequency patterns in the motion substrate.
Microwaves.
Tighter, more compressed patterns, synchronizing faster, visible light, incredibly rapid cycles.
And X-rays.
Ultra-compressed, super high-frequency motion patterns. It's all just different scales and frequencies of the same underlying phenomenon. Structured motion.
And does this connect to the quantum world too, like photons?
Directly. In quantum electrodynamics, QED, the photon, usually seen as a particle of light, gets reinterpreted. It's seen not as a point particle, but as a quantized, distinct packet or chunk of this structured motion rhythm.
Ah, okay. So this really highlights Maxwell's legacy for motion theory, even if it wasn't his explicit framework.
Precisely. Mainstream science sees his equations describing field relationships. Motion theory sees them as maybe the first mathematical proof that motion alone can create these self-contained, self-sustaining patterns.
That feels like the core aha moment here.
Yeah.
He didn't just unite E and M.
His work, through this lens, hints that maybe all fundamental forces are just different arrangements of this motion.
So if you extend that logic, gravity isn't some separate force.
It could be interpreted as a universal motion convergence gradient. A general tendency for this background motion to flow towards areas where motion is already more concentrated or dense, like mass or energy.
And the nuclear forces, strong and weak.
Perhaps just very tightly bound, highly constrained motion patterns happening at tiny subatomic scales. Different arrangements again.
It really elevates Maxwell, doesn't it? In this view, he gave us the evidence that motion doesn't need matter to exist or propagate.
He showed that patterns of pure motion can sustain themselves, and he gave us the math, the language, for how motion transforms between different forms.
He essentially found the pulse of the universe's motion.
Gave motion its visible heartbeat, you could say.
So wrapping this up, James Clerk Maxwell, obviously he didn't call it motion theory, he didn't need to name it that, but his equations, in their elegance, already hinted that maybe all these forces we see are just different ways motion structures itself.
Yeah, without him, we might still be thinking of electricity and magnetism as totally separate, almost magical things.
But with his work, especially viewed through this motion theory lens, we can start to see them as, well, not two things, but one loop.
One rhythm.
One fundamental motion.
Exactly. When you see it that way, Maxwell's equations become more than just electromagnetism. They suggest a universe built not on separate forces, but on these structured, dynamic patterns of pure motion. He gave us this profound mathematical insight. Motion can be self-contained, self-sustaining, endlessly dynamic. He really did reveal the universe's pulse.
So here's the final thought to leave you with. If the very fabric of reality is defined by these self-sustaining motion loops, and if light itself doesn't need anything material to move through space, just these patterns sustaining themselves, what does that imply? Does it change how we think about consciousness?
No.
Or maybe even the origin of the universe itself? What new questions pop into your head when you really consider the idea that maybe it was always just motion? Something to think about.